Till now, you have seen different types of derivatives, correct? We looked into the normal differentiation, then we have logarithmic function, exponential, inverse trigonometric, and we also did parametric. See, everywhere, whenever you differentiate it, you are calculating dy by dx or something related to, but then everything was just one particular type of differentiation, that is just dy by dx, correct? Now, in this video, you are going to understand about second order derivative, all right? Or we also call it as double differentiation, all right? See, when we have differentiation, suppose if you have y, say y is equal to sin x, a very simple function. Now, first order derivative, in the sense, you're going to differentiate the function once. That means here we do d by dx of y is d by dx of sin x, correct? It's a derivative. So we write this as d by dx of y is equal to cos of x. We know the derivative of sin is cosine. Now, double derivative in the sense, see, you have already differentiated the function once. You are going to differentiate the same function one more time. So, double differentiation or second order derivative. This is the first order derivative. The next is the second order derivative. Clear? So, what we get is the second order derivative. We represent it something like this one. See, we have d by dx of y. Now we are going to get d by dx of y. Correct? This is going to be d by dx of cos x. So LHS becomes d square by dx square of y, which is minus sin x. Or in other words, we write this as d square y by dx square. This is one. Or this is the same as writing y double dash. Y dash is single order derivative. Y double dash is the second order derivative. Or we can also write the same thing in another way, which is y2. 2 is in the subscript, not in superscript. Superscript becomes square. The subscript becomes y2, the second order derivative. Fair enough? So, these are all different ways of representing the second order derivative. Clear? Now, let me show you few examples. See, in double order, second order derivative or double differentiation, some of the problems are finding the derivative. Okay, the second order derivative. But most of the problems what we have is proving sums. Alright, so given y is equal to this, prove that this is equal to this. Most of it is a proof. Alright, most of them. I would say around 60 to 70% of the problems are proving sum, and the remaining is all finding the value of double derivative. Clear? So now let me show you few examples of how do we calculate the second order derivative. Alright. See this particular example. Say we have y is equal to, let's take a little complicated function. Alright. Say we have sine square 3x. Assume this is my function and I'll ask you find the value of y double dash. Y double dash is how much? Fair enough? Now, first we calculate y dash. Here use chain rule. 2 sine 3x into cos 3x. Then we go for the inside function 3x here. Isn't it? So, if you go there, it's going to become into 3. Or you can call this as 3 sine 6x. Because 2 sine a cos a is sine 2a. So, sine of 2 into 3x sine 6x. Y dash becomes 3 sine 6x. Now, y double dash becomes Remember, you need to differentiate this function, correct? So when you differentiate this function, so we have 3 cos 6x into 6. The derivative of 6x we need to do, which is basically 6, correct? So at the end, we have y double dash is 18 cos 6x. This is going to be the final answer. Clear? Now, this is how we calculate the second order derivative, or you can say double derivative of a function. Fine. Now, in the next video, we'll directly start with problems, because see, it's just derivative itself, but we are doing the derivative of again one more derivative, double differentiation. All right. So we have log function, implicit function, a parametric function, whatever you have studied so far, we can calculate the double derivative of each and every function. All right. And that is what we are going to do from the next video. All right.